Alrighty then. Hello, everybody, and welcome to the stream. I hope everybody is doing okay tonight. RCW, good to see you. Welcome. So, yeah, we were offline last week. I just needed to take some time to rest up. Been battling some issues lately. Nothing too crazy, but just wasn't feeling the energy levels right. So I figured I should just take some time to rest up and come back stronger this week. So that's what we've done. We are here, and we are going to be tackling some more of this refactor stuff, hoping to close the loop on this really soon. If not tonight, maybe in the next stream. We'll see. So, Tammin, good to see you. I'm doing much better than last week, that's for sure. Still not 100%, but, much better. So thank you for asking, though. Appreciate it. Before we jump into things, I do want to just take a quick second to thank the supporters of the channel, starting with the partners. They are the highest tier of subscription over on YouTube memberships and Patreon. They are Dustin Punt, Gabby Bashir, and Gerboles Inc. I would also like to thank all the other supporters listed here. They are a combination of the other tiers of support over on Patreon, YouTube memberships, as well as Twitch subscriptions. So thank you all very much for your support. It's greatly appreciated and helps me grow the channel. So thank you for that. And of course, thank you all very much for being here, the viewers, whether you're here on the Twitch side, whether you're here over on the YouTube side. We do simulcast to both. I do watch both chats. So thank you guys for being here. I appreciate each and every one of you. Arden the Coder, thank you for the follow. Appreciate that. Spiro, good to see you, buddy. Thank you for the welcome back. Appreciate it. All right. Let's see. Oh, Arden the Coder, you're on both sides, actually. Thank you for that. I appreciate that. All right. So, I do want to talk just for a second about what some of the things that we've done offline, because I did try to sort of maintain a little bit of pace with this. Even though we didn't stream last week, I did want to at least make a little bit of forward effort. So there was some stuff that I went ahead and did offline that's probably could briefly go over here. I don't know how valuable it would be. It's most of the same stuff that we've seen, but in order to keep things moving, I just kind of did some of that stuff offline. Opanda3 and Rudimbo, thank you for the follow. Appreciate that. So, I'll just open up a quick terminal here, and we'll do a git log. So, I did complete the refactoring of the standard UI. Most of this was just plugging in all of the changes that we needed for some of our interface stuff. There is some changes that we're going to need to do for the plugin itself to actually get it loaded, but the library now compiles. I also completed the refactoring of the Vulkan plugin, so that compiles as well. And basically where we're at right now is we are in the middle of, we are in the middle of refactoring our library for our testbed, right? And I've sort of already started on that as well. So if we do a git status, I've already done some work on that as well. I can actually scroll this up so you guys can see it behind my noggin there, right? So I've already done some refactoring around some of these files, just trying to get stuff to compile at this point. That is the first goal, is to sort of get everything stitched back together and compiling, and then we will debug through it. So we've actually come a decent amount of way through the testbed library as well. I think the only major file we have to really refactor or do any serious amount of refactoring in is the testbed main file. And so that's what I'm going to do tonight. And then once we get everything building, we will just sort of kind of go through and stitch together the parts that we forgot, because obviously with this huge refactor, I'm sure I forgot a multitude of things. So, with that said, let's go ahead and get rid of this. And get rid of that. And we will pick up refactoring on the testbed main, which is what I have open here. All right. So, as you can see down here, we've got 96 errors in the file. This is down from 150 something that I had when I started this. So we've made a pretty decent amount of headway through this, rather. Most of these errors, I think, are actually surrounding the standard UI stuff. And most of that is because all these standard UI calls to everything within that system now require the state to be passed in, right? So we don't have sort of this, the static state that was sort of maintained before. Now it's required to be passed around, right? And that's just how we're going to kind of manage this, at least for the standard UI. So we have that, and I think most of the errors in this file are actually from that. So with that said, one thing that we do need to do is we actually need to make use of our new external system registry, as we call it. And basically what that is we have, so for just a quick review of what our systems are. In our, let me get rid of this, in our runtime, we have a collection of systems, right? So our audio system, our camera system, our font system, all these different systems that manage various things, right? And all the startups for these things are all, and the life cycles of them are all managed by the engine. And that's fine, since the engine exists within the runtime. It makes sense that, the engine knows about all of these types that are included here. However, what do we do about systems that are external systems, or systems that are exposed via a plugin? We still need some sort of way to manage that. And there's a couple of ways we could do this. We could use the plugin system to say, okay, well, each plugin has a state, right? And we could essentially use the plugin state to act as that. Or we could have an external registry that the engine can use, where a external system can register with that upon loading, and we can obtain the state that way. So one such thing that we've seen with state being utilized quite a lot is, if we take a look in, let me actually close this real quick. If we take a look in, let's take a look at our, our forward render graph node, for example, right? We have, when we stand this up, we keep a copy of the renderer system state in here. So that calls to the renderer, we have the state that we need, right? And when we stand this up, we do a engine systems get, right? And this returns to us a structure which contains all of the core systems to the engine, right? Which is nice and convenient for known systems within the engine. But we don't have any sort of, or at least I should say we just haven't used yet, a method to actually get externally registered systems, right? So systems that don't necessarily have a place in this structure. So what we're going to do is we're going to register our new system, and then take a look at pulling back out something from that registry that we're going to need to know. So we're going to see how that works. It's something that I sort of prototyped but haven't really used yet. So we may run into some issues there, but it's unexercised code. Omniscient, good to see you. How's it going? Let's see. Stream is stuttering on YouTube, or is it just me? Is anybody else having issues with the stream on YouTube? YouTube's telling me I have an excellent connection, so I'm not sure if it's just you or not. I don't really have a way to verify that, unfortunately. Is it the video or just the audio that's stuttering, or both? All right. So I'm going to open up. Oh, it's the audio. Okay. Yeah, I don't see like I don't see any dropped frames or anything in OBS. In fact, I've got 0 dropped frames in OBS. And YouTube is reporting an excellent connection, so I'm thinking it's possible that it's just you. If you're on Windows, maybe reboot. Seems to solve a lot of stuff on Windows. Okay, so let's do the standard UI system, right? Our standard UI system is an external system. That is not part of the core, right? So it needs to sort of register itself with the engine. And I don't believe I've actually done this step because I kind of wanted to leave this until we actually streamed because this is something we haven't really done yet. So, okay, it does not look like I've done that. All right, perfect. So when we stand up the standard UI system, we do save off a pointer to the renderer because the system needs to know that. In fact, I put a fixed me here, right? Engine external system register memory requirement. Not sure if this should be here, done here, or where the plugin is initialized. So that's a good point. I would like to think that we should probably do it here. So if we take a look at this API, the way that this works is, in fact, I'll just open up this guy. So what we have is an internal registry, right, where we can add an entry. And essentially, this is just a K registry that we set up, right? So this is sort of a new little system that kind of tracks different things for us, right? Specifically, things with callbacks, right? So in this, in the registry, when we create the registry, it's essentially just a flat array of entries, right? And if we take a look at entries, an entry is basically just something with a unique ID, a block size for state, right? The actual block of memory, how many things reference it, and whether or not that particular entry should be released when the reference counter equals 0, right? So we have something like this very similar to like our texture system and things like that. This just essentially, instead of just managing textures, this essentially keeps a listener or a list of callbacks, right? So essentially the way this works is when we look up a registry, we look that up using handle, we loop through this array, and when we find one that matches, we go ahead and return it, right? So when we add a registry, or I'm sorry, add an entry to the registry, right? We pass the registry, the block of memory, the size of that memory, and whether or not it should auto-release, right? And it returns a K handle. And then that K handle would need to be used whenever you're going to actually obtain that particular entry, right? So if we go ahead and let's see, it should be acquire, right? Which acquires a single reference to that entry. Essentially what that does is returns a block of memory, right? Which is just void in this case, and then it'd be up to the caller to sort of cold cast that. And so to get this, obviously we would pass the registry, pointer to the registry itself, the entry handle, right? So that's that entry handle that we would have gotten back, a listener, and then whenever the entry is updated. And that's pretty much it, right? I'm skipping some details there that aren't really important as of yet. We'll go into them when we actually start using this, but that's more or less the way that the entry system works. Or the registry system works, rather. So standard UI, C. So this is the way that we register one of those things. Engine external system register, right? So all this actually wants at this level is the memory requirement, which actually I'm already seeing a problem with this. So this only allows us to actually declare what the size of it should be, right? Since the system should call get state next for it. Yeah, so we're saying then that the memory block should be owned by the engine and its registry, which is true. Do we expose a way to set that, though? I don't think we did. So we need a way to be able to set the memory block for that, which I don't think we actually exposed. Which is what this is for. So whenever we set the block of memory, we essentially just say, okay, for this registry, for this handle, set the block of memory to this. Here's the new size, and then here's a pointer to the thing that initiated that call. And the reason we might want to do that would be in hot reload situations, right? If we had this block of memory owned by something else besides the engine, and we hot reload the DLL, then it's possible that this block of memory may have changed, right? And so that would be why we would ever want to set that. But I'm thinking, the more I think about it now, we probably shouldn't require that when we stand it up, right? We should actually have a way in the engine to be able to pass a block of memory. I'm thinking. Unless we should, maybe we should, although if we do it this way, we would need to get rid of the initialization call in the standard UI system, which is also a little bit weird. Okay. So I guess there's technically three ways we could go about that. And the more I think about this, there's another issue with this too, actually, now that I think about it. So here's the other problem. This returns a K handle, right? Which we're going to need to store somewhere in order to get the state, right? The problem with this is, where do we store the handle? We can't store it in the system state, right? Because we don't have the system state. That's how we get the system state. So it's almost like this can't happen here. It's got to happen somewhere else. Right? It's got to happen by whatever actually stands this system up, which would be the plugin. It's the only thing I can think of. Yeah, I think that's I think that's what we're going to have to do. And that's why I had the fix me there, because we are going to have to move that. Okay. All right. So maybe now is when we do the plugin stuff that we sort of alluded to that we haven't done for this yet. And by the plugin stuff, quick refresher on this as well. I think it was in entry.c, which this is another section we're going to have to touch. This is where we have all of these sort of gross loading code for all of our plugins, right? Specifically, let me find it. So it looks like I guess we fixed this for the OpenAL and Vulkan renderer plugins, but not the standard UI. Where is that actually loaded? It's not in here, I don't think. Where did we actually load that? Oh, we're manually registering it with the systems manager here, which we haven't handled as well. Which also means that this is probably statically linked with the application. All right, not the end of the world. So yeah, I think the plugin system is going to be the correct way to handle this. The more I think about it. Let's take a look at the plugin system. Oh, that's interesting. We have a left off in here. Is this actually done though? I think this is done. Okay, build up a system that can load plugins by configured names, which is then used to load shared libraries. It will then load up the kruntime plugin functions that are available, set the state, and register it globally, available to be queried later. I think we already have all that stuff in. This should happen early in the boot up process so that systems have backend plugins that have backend plugins like the renderer and the audio have what they need by init time. I don't think this is really a left off anymore. This is done. Okay, so our plugin system currently, we initialize that. That's done in the engine. Shutdowns, obviously, engine, update, frame prepare, render. Those are lifecycle things. These are all called by the engine. Load plugin happens based off of configured plugins. And then we have plugin system get, which is where we can get a plugin by name, which would be the same name that it's configured with. So the application would actually want to call this. That would return the kruntime plugin, which contains plugin size, or state size and state, right? So that's just a block of memory. And then function pointers. So that means that all of our plugin loading logic should go away from the entry and be replaced by configuration, which should load this. So if we go to app config, we have plugin system. We already kind of started scaffolding this out. So this should already be loaded. Actually, we shouldn't have to do this manually. Right, so let's grab this name. And we'll go back to testbed main. And at this point, we should have everything that we need in order to be able to get the plugin, right? The plugin should be loaded like way before application initialize is actually called. So, k runtime plugin. And we're going to call this SUI plugin equals plugin system get. This is going to be engine systems get plugin system. And then for the name, we have that. Right, so get the standard UI plugin. And now that I think about it, this plugin, the state itself can be the standard UI state. So actually we don't even really need, we don't need that whole registry system, I don't think. I think we can actually get away with saying, hey, the SUI plugin, so the SUI plugin state, right? This block of memory right here is the standard UI system state. Do we not have? All right, I'm just going to void pointer this for now. UI state. Pretty sure we actually have that type somewhere, but okay. So at this point, we really do just need to configure the startup and initialization of the standard UI system to work with this new plugin interface. Because if we set that stuff up, then this will just work out of the box and we'll have exactly what we need to fix 90% of the errors in this file. So when we go to do standard UI system initialize, what actually needs to call that is, I think, going to have to be a new file, because I don't think we actually have. I don't think we have like a plugin main like some of our other stuff does. Oh, yes, we do. But it's not filled out. Okay, cool. Well, that's neat. So we're going to have to fill that out. So let me think about what is the plugin system. Actually looking for when it goes to load this thing up. So plugin system initialize, plugin system update, prepare, render, load plugin. Here we go. So load plugin, drag this over a little bit. It's looking for a kplugin create. All right, and it needs a kplugin create and a kplugin destroy. And then all of these other potential hook functions, which a lot of those will tie in nicely to our standard UI system anyways. We could actually just call our standard UI system using that. So, plugin create, that is going to be a function pointer that looks like, oh, you know what? I'm actually just going to do this. Let's grab all of this. And we're going to go to ads. Let's see. Angela, I do see your question over on YouTube. I will answer it when I come back from ads. We've got, oh, I updated OBS again, and now it's reverted my display to say an hour and a half of ads again. That is 90 seconds of ads, not an hour and a half. Every time I update OBS, it breaks that script. It's super annoying. Ruche, thank you for the Yar bongos. Appreciate that. I should have checked that when I ran the update earlier. I'm going to write that down. I'm not going to bother fixing it while we're on stream, but I will fix it. I'll fix it after the stream. All right, so we got about 20 seconds, 15, 20 seconds left. And then we can get back to it. All right, so Angela over on the YouTube side had a question. Can you create the second half of the engine layout diagram and post it? It would help to give some orientation as to where things are heading in the short and long term. Yes. That is something I'm actually working on offline that I'm going to probably wind up just putting up on the repo and showing at some point. It's not done. But yeah, with all these architectural changes that we've made, specifically in this refactor effort, along with some of the stuff that's changed as the series has gone on, it looks quite a bit different than it did in that original diagram. So yes, we are going to put that up, but I don't have an accurate one to display at the moment. But yes, we will be doing that. In fact, I'm going to write that down too to finish that up and see if I can get it done by maybe tomorrow's stream. Even if it's a quick and dirty one, you know, I'll get something up. But yeah, that's a good point. Thank you for bringing that up because it's something that I keep forgetting to finish up. Okay, so we have our functions that we're going to need, and I believe these all have to be name-specific things. Yeah, like k plugin create, k plugin destroy, initialize update, frame prepare, render on window resize. So I think actually, oh, did I forget to paste window resize? I probably did. That's fine. Let's do why have you done that? Okay. Peak definition, let's grab this. And put it there as well. All right, so we're gonna export all these first. All right, and we're gonna call this k plugin creates, right? And that's essentially what it's going to look like. We also need to include defines.h, right? And that's from the kohi core. And we're going to need to for declare some stuff. So struct k runtime plugin, and frame data. Right? Pretty sure there's another one too, k window also. Right, which is, that one's actually kind of irrelevant. Actually, it's irrelevant for our audio plugin, right? It's actually relevant for this one. All right, so let's see, what was it supposed to be? K plugin? Okay. So how about we just do a pfn k runtime underscore, right? And we're just going to replace that with that, just a K. I think it's just K plugin. Yep. We're going to do that globally, right? And then we'll just get rid of these. All right. So these are essentially what we need to declare and fill out for this particular plugin, and then we can forward those on to our actual internal system, right? So let's take these and go to standard UI plugin main C, and we'll just paste these all here, or not. Try that again. All right, and we'll include standard UI plugin main.
Hello, long time no see. Hope it's going well.
Diamond, good to see you. Thank you for the tier 1 resub. I appreciate that. 7 months already it's been. That's awesome. I appreciate that. Thank you very much. It's going pretty well. We're hopefully closing up the loop on this refactor this week. So, or at least we'll be at a point where we can compile. I'm hoping tonight, so we can actually start debugging through the issues. But yeah, it's going pretty well. Let's see. Manu. Holy crap, brother. It's a long time since I've talked to you. How's it going, man? It's crazy to see you in my chat. Welcome. Axeris. I'm feeling much better this week. Thank you for asking. Appreciate it. No stutter in your end, Manu? That's awesome. Thanks for hanging out, man. Long time no speak. How are things going for you? All right, so let's take these and convert them into definitions. It would help if I hit the right keys instead of continuously hitting the wrong keys. That'd be neat. Fixed point overflow. Good night. Have a good one. Still chugging away at scripting language. Have a full interpreter. Working on bytecode translation. That's awesome. Yeah, I'm not looking forward to doing that when we get to that point. Right? Because writing a storage format is one thing, but writing an executable scripting language is another. That takes a lot of work, for sure. I might wind up doing parts of that offline, actually, when I get there. But that's really cool that you're making good progress on that. You're building the interpreter into a plugin in Zig, since it has great CNROP. I get that. Spiro on here would definitely be interested in that for sure. He's a big... He's like the Zig guy here on Twitch, for sure. He'd be all over that for sure. Which I'm actually going to give Spiro a shout out real quick. If you guys aren't following him, you should be, because he's always doing all kinds of interesting stuff on his stream. Although, you know, sometimes he has to do like co-working work stuff, but he's building a game using Zig, WebAssembly, and he's using the browser DOM as his renderer. So, yeah, he does a lot of out of the box stuff like that, and he's a really chill dude, one of my good friends, and I highly recommend following him if you aren't already. Of course, Spiro, you are the Zig guy. Yes, 100%. Interpreterbook.com. Read this book. It was great to learn the basics. I'm going to bookmark that. And I will drop this over here for our YouTube chat as well in case anybody wants it. Good stuff. Okay. So our K plugin create is going to do now what we were doing in the testbed main to start up our UI system. Kinda, right? So we were doing this systems manager register where we register the UI system, except we don't have the systems manager anymore. So really what we need to do is manually call these functions. And this config here. So actually what I'm going to do is I'm going to take this block of code, go over here, plop that right there. And the first thing we're going to do actually is say if we don't have out plugin, oops, then we're going to do say k error cannot create a plugin without a pointer. I don't know if I can spell pointer correctly, to hold it, you dingus. Turn false. Right? That'd be dingus-oriented programming to call it that way. All right, standard UI system config. We should be able to just include that guy. And then we're going to actually split this apart, right? So we don't have any of those symbols anymore. None of that stuff exists. And we're going to say standard UI system initialize. And I know that's just sort of stubbed out for right now, but that's what we're going to do, okay? We're also going to do the same thing with shutdown. And then we're also going to do the same thing with update. I realize we're missing arguments here. It's fine. This is all fine. All right, and then actually we can get rid of all of that. All right. Okay. So the first thing that we're going to need to do is our initialize call. I believe is the whole double call thing that needs to be done, where we get the memory requirements, stand up some memory, call it again, that kind of thing. So let me see. So the K plugin create. The only part I don't remember is, was that responsible for creating its own block of memory or not? Don't remember that. I don't think the plugin system did that. I think it was up to the plugin to do it. New plugin. So when we load the plugin, all we give it is a config. Yep, we just push it onto the array. Okay. Okay. So let's go ahead and we will set that up then. So we'll do, I guess we can set up an internal state for this, right? Should it be internal? Should it be internal? So it's saying that the state could be the UI system state itself, but I'm thinking I should probably actually split those two things out. Because we might need to hold some information there that maybe isn't included elsewhere. Let's put this in the header file for now. So we'll do UI plugin main. Let's declare a new struct. We'll say typedef struct standard UI plugin state UI plugin state. There it is. And we're going to say U64 state. Let's say SUI state memory requirement. And we'll do a void pointer. Or actually, we don't even need to do a void pointer. Actually, we can do a struct SUI, or was it standard UI system state. Plugin system state. Let me see. What did the standard UI state is what I called it. Okay. So standard UI state. There. We'll go ahead and do struct standard UI state. Okay. So those are the only two things I think we're going to hold in there for right now, but I have a suspicion that we're going to need to hold some more. So to this, let's see, we just need the memory requirement and potential config. Okay, so we'll allocate the plugin state first. So we'll say out plugin. Plugin state equals k allocate, and we're going to say size of, and we're going to say standard UI plugin state, and the memory tag on this. What do we want to use for the memory tag? Why does it keep putting me to the last line? I keep hitting the wrong button apparently. let's see. I guess we can do... We don't have plugin. We do have UI. I guess I can use that. We probably should have a memory tag for plugins. I mean, I could use UI, but that seems kind of poopy. So we have this standard UI plugin state. Why is it not picking up this? Oh, because I had to save. All right. So let's do that. And what is this bleating about? Incomplete definition of struct k runtime plugin. Great. So technically we should probably do include plugins, plugin types. Right, so that'll give us that. We also need to convert this and that. Right, and we'll move this up here, move those down here. Actually, I should probably do the opposite. Okay. So that's our plugin state. So we allocate that. Then to the plugin system, or the UI system initialize, we'll pass the address of out plugin state. Oh, you know what? I have to cold cast that, don't I? So let's do standard UI plugin state. We'll just call this state equals out plugin state, right? And now I can just say state.sui state memory requirement. We're going to pass 0 since we're just obtaining the size that we need to allocate. And then we'll go ahead and pass the config. That's fine. So standard UI config, pass the address of that. Then we'll do a out plugin, or rather state. I should probably call that plugin state instead of just state. Equals k allocates, and then we want the state SUI memory requirement as the size, and the tag. I guess we'll just use UI for right now. I'm going to fix that in just a minute, I think. And then we go ahead and we call this guy again, this time passing state. And we say if that fails, then we do a k error, failed to initialize standard UI system. Turn false, right? So we sort of have a state embedded in a state. I'm just going to call this, I'm going to call this plugin state instead, right? So we have plugin state and then state. Okay, so that covers our initialization, right? Which I suppose we could actually theoretically, we probably shouldn't do this until actually this phase of it, right? Really all we should do here is fill out the plugin state. So out plugin state size is actually equal to that, right? Which I guess let's just use the same thing here. So we'll say out plugin state size. So I guess let's actually split this up. Let's take this down here, put that in here, right? Can't return false there because it's return type void. I suppose that's fine. This is just plugin. All right, so we get the internal plugin states, initialize the thing, and then move on from there. Why did we set that up to be void for initialize, right? Shouldn't we know when a plugin fails to initialize? It feels like a bad interface looking to bite us, right? So I guess let's change this type. So the initialize, yeah, so create returns void, or returns a Boolean, but initialize doesn't. So this should actually return a Boolean. Destroy can remain void because if we can't destroy it correctly, the OS will clean it up anyways, who cares? But that should definitely be changed. Okay. Which makes me wonder, when we do plugin system initialize, plugin system load plugin, so we load all the function pointers. We do create, but we never actually call initialize. And also, why do we have initialize here twice? What is going on here? Some sort of copy pasta bananery. This should be frame prepare. That's another nasty bug that would have caught us. That should be frame prepare. Initialize. Okay. So we register the plugin. Which really is all that load should do. But do we not initialize these at any point? We don't actually have... We don't have an initialization routine here. How did we miss that? Dingus style after tiger style. Yeah, exactly. Very proud of the little implementation, and I went all in on the data-oriented design. Awesome. Did you do dingus-oriented programming, though, is the real question. Because that's what we do here is dingus-oriented programming. You did. Awesome. Approved. You have a few dinguses in there. Awesome. Speaking of dinguses, we have ads. So for those of you who are over on the YouTube side, over on the Twitch side, we're served ads for up to 90 seconds every 30 minutes. So I like to pause the stream so that nobody misses any content. I realize the timer on the screen right now says an hour and a half. That's because when I updated OBS, it breaks my script every time, and I forgot to fix it before the stream. So I have that written down to fix before the next stream. It's a quick fix, but I don't necessarily want to do it in the middle of a stream because the last thing I want to do is chance crashing OBS. So it shows an hour and a half there. We do not have an hour and a half of ads. We have up to 90 seconds. And so, yeah, I usually put that timer up there as a sort of reminder as to, when we're coming back. So that you guys, if you wanted to go hydrate or something like that, you can do that. But that doesn't really work when the timer is wrong. So sorry about that. We'll get that fixed before the next stream. I think part of the issue is because the default timer in OBS only works in minutes. And I updated it to do seconds, and every time you update OBS, it changes it back to minutes. So I may have to actually just change the script, I guess, so that it doesn't get overwritten and nuked every time we update. But anyway, I need a copy of the Dingus Manifesto. I'd love to join. Is dingusmanifesto.com available? I mean, it could be a thing. That's the important question, right? We ask the important questions on this stream. If we're going to have the Dingus Manifesto, it's got to have a .com. Just saying. I might need help writing the Dingus Manifesto, though. I should do it, right? I own so many stupid .coms, though. Probably the stupidest one that I own. For those of you who have been on the internet for a while, might recognize this meme. But I just registered I can't believe you've done this.org. So for those of you who are interested to see what this is, I'm not going to play it on stream, but yeah. I don't want to get DMCA'd, right? But it's there. All right. Stupid domains aside. Let's create this memory tag. I don't want to get away from this, right? Because all of our plugins aren't going to have something to use like this. And that's not really what I want to do here anyway. So creating a new tag is pretty simple. It's just in our K memory. I'm just going to add it to the end. So we'll do memory tag plugin. All right, so we add one entry there. And in here, we have a lookup for when we're printing it out for debugging purposes. So in this case, we're going to do, I guess I could just, plugin should fit. Right? So now we have that. Let's change these to plugin. Okay. So all of these other things could be moved to the other callbacks here. We were looking at, though, so we had plugin system initialize, plugin system shutdown, and then we have update, frame prepare, render, on window resize, and load plugin. So we have a bit of a naming conundrum here, because we have the plugin system initialization for the system of, that manages the plugins here. But then we also need something for our plugins as well, which makes me think that these are actually named wrong, right? Because technically what these are doing is these are, this is updating the plugins. This is doing frame prepare on the plugins. This is doing renderer on the plugins, window resize, etc., right? I wonder if I really should just tie it into the loading. Like when we load the plugin, do we also just initialize it and call it a day? Maybe we do. Maybe we do. I think that's what I'm going to do. Maybe before we register it, right? So we'll say invoke the initialization of the plugin. If this proves to be a problem, we can always move it. So we can say if new plugin, k plugin initialize, right? So if that exists, then we want to do a negative check against that, right? So we'll say if new plugin dot k plugin initialize. So if that fails, and that's going to need the address of new plugin. So if that fails, then we'll do a k error failed to initialize new plugin during creation and return false. Right? And that, I believe, only requires, yes, a pointer to the plugin. Okay, so that should work, right? So when we load it, we'll do plugin create, and then we'll immediately call initialize. Note, may need to move this if it proves to be happening too early. Let's see. Xcarnate, first time chat, welcome. A few years ago, I forgot I had a parody political site that had a static image. Kept wondering why I was losing $278 a year. Worth it. Yeah, exactly. Literally, all that page is just, it just has the embed of a YouTube video on it, right? Widular, good to see you. How are you doing? Spiro, can you be the Zig guy? How can you be the Zig guy if you don't stream? Ooh, Arvis got you on that one. Started using VK extended shader object, makes everything dynamic state plus no pipelines. Literally does pipeline caching behind the scenes. No pipelines would be nice. I haven't looked recently though. Like, what's the support like on that one? Like, desktop GPU support. Because if it's near like what dynamic rendering is, then I might actually wind up doing that too, because pipelines are kind of annoying as well. All right. So we've initialized, that will make sure that this gets called. So here we need to return true there. Put these here. This one needs to be changed to a B8 to match the interface, which means this can now be return false again or return true. And I only don't return this because there may be other things that we need to do alongside that. So, plus I'd like to spit out an error message. So kplugin destroy, let's see. change this type here. That should be a B8. All right, and of course, we actually need this here. All right, instead of out plugin, just have plugin. So cannot initialize a plugin without a pointer to it. You dingus. Okay. So
3 months. Let's go. I hope you're feeling much better this week.
Yak and Shears, good to see you, buddy. How are you doing? Thank you for the 3 months and the resub. I appreciate it. I am I'm feeling better this week, yeah. Not 100%, but better. Yeah, for sure. So I definitely appreciate that. How have you been? It is good to see you. Let's see. So the extension shader object works with 1.0, yes, technically speaking, but what's the hardware support for that, right? Because just because it works with 1.0, it's still technically an extension, which doesn't necessarily mean that it's supported across the board, right? I suppose I could just look it up real quick. Let's see. Shoot, what was that device? Here we go. GPU info. Let's look up. Let's look up extensions. Is that like literally... Did I type that wrong? Oh, it just took forever to come up. Okay. Let's do, I guess, Windows. It's not very promising. Device coverage is pretty low. So unless I'm doing something wrong here, like, yeah, I don't think that's very widely supported. Yeah, shader objects, yeah. I think I like briefly, I remember reading about this at one point and then immediately backing away from it because of that. Or version 1.3. Okay, so I guess if we're on 1.3, then maybe we'll be fine. I don't know. I'll have to look into it. It might be worth doing, right? Because I did at least go the dynamic rendering route. Comes at the cost of speed. Yeah. I mean, but like, I do wonder how much that cost is, right? Has a layer to translate to pipeline code, so everything that supports Vulkan, basically. Okay. Yeah, so I mean, you know, is it like a 1% hit, or are we talking like a 12% hit? You know, that's the question. I guess I would have to profile it, but that's kind of I wouldn't want to do that with all the extra engine stuff going on here. You know me, I'll pick ergonomics over speed way more than I should. Yeah, I'm trying not to do that, but sometimes it is. Sometimes that trade-off's worth it, right? But like, more often than not, it isn't. All right. So we've initialized that. The shutdown. The shutdown needs to go there. Put the update there. The prepare frame there. We do have a render for this, I thought. I thought we did. Anyway, I could be wrong. So let's see. We do. Yep, I thought so. Okay, so we have all the entry points that we need. Right, so we just do that. The only thing that we're going to need is we're going to need a little bit of stateful information, right? So we are going to, in fact, need to use our plugin state for some stuff here. So basically, we go from frame prepare to render. There's some lifecycle stuff that's going to have to be essentially copied or held onto from here to here. Not a huge deal, but something that does need to be handled nevertheless. Don't we have... We do not have resize logic. That is interesting. So I guess we didn't take that into account yet. So we do want that. So I'm just going to mark this as a to-do. But we don't need to get it done right now. All right. So the first thing we'll do for this, since it's return type void, is we'll just say if plugin. Right. And then we'll need to get the plugin states. We'll just grab this. And we need plugin state. And I think that's all this requires. Right? Okay. So there's that. What's going to be interesting is to find out when these things are actually called, right? These, like the update doesn't really matter, the frame prepare doesn't matter, but the plugin render does matter when it's called. The time at which this is called is actually imperative to proper operation. This is because the UI typically should be drawn as the last thing in the frame. Might not be able to use this entry point. And I'm actually thinking we're probably not going to be able to use this entry point. We might actually need to put this into frame prepare. And the reason I'm thinking that is because it needs to be last. Technically, our actual draw is going to happen within our UI render graph node during its execution, right? So this is essentially going to prepare for that execution, and then the execution of the actual node itself is what should happen essentially here, but at the last point in the frame in the render graph, right? We should be able to determine that in the render graph. So I suspect that this is probably going to wind up having to be moved. This probably needs to happen in frame prepare above. All right. I think that's going to be a problem. In fact, I'm going to change this. I'm going to upgrade this to a fix me. All right, so we need We need this logic a couple more times. Right? Except I'm not going to error every single time on one of these guys, right? I'm just going to say, if we don't have it, return false. Be done with that. This does return a Boolean, so I'm just going to return that for now. We do need the plugin state. Plugin states. What else does this need? Frame data. Okay. We have p frame data. Right. So we have that. Prepare frame, I think, is much the same kind of deal. It is. So we can do plugin states, state, and p frame data. And then we'll just return that guy. Returning void. Oh, prepare frame is void. Okay. I'm gonna let that slide for now and just return true. Because I don't know if there's anything in there that can actually fail. So I think I'm just gonna let that rep for now. And then in the render I believe does return a Boolean. So we need, again, the plugin states. I'm just going to plug this in here for now. Plugin states. Root. Do we have that? Do we have that? Let's do standard UI system render. Okay, this was done by the render graph before. Well, it looks like we are passing a null pointer there. So maybe that just says use the root. We might be good there. What is this? Let's go ahead and pass null there for now. Then we have p frame data. And then we have the standard UI render data that we would have grabbed from here. System render. What were we passing here? Extended data, SUI render data. So the extended data here, the renderables. Where did ext data come from? That is the... We're storing that in a render pass. Gross. I'm glad we got rid of all that stuff. Okay, so that's the bit that we're going to need to store. That is the bit that we're going to need to store in the state. Okay, so let's actually do this. Right? Whoops, I need that one more line down. There we go. Include that. Right? And then we can just say plugin state render data. Now the question becomes, the prepare frame is going to have to somehow like write to that. Unless that's what the render does. I don't recall. I'm going to have to refresh my memory on that. Let's have a look at what this guy actually does. So we pass in the render data, set the atlas from the state. If root is empty, or if we don't have root, then we use the state root. That makes sense. Okay. And then we call render throughout all of them. Passing through render data. And this recurses down. So the root render has got to be what writes that render data, if I remember correctly. It's only been about a year since I wrote this. Yes, because we have UI, Atlas, and a list of renderables. That list of renderables is push to for example, right there. Okay, so the rendering, in this case, the render doesn't actually render a dang thing. All it does is essentially build a list of things to render, which is actually exactly what we want. So I was right about this. That needs to happen at the same time, right? And then I'm going to get rid of that. Standard plugin main. And I'm going to comment that one out with a note saying actual rendering handled by node configured ads. Let's see. And FYI, I am aware that the ad timer is wrong. I'm gonna fix it before the next stream. Let's see. No point in ditching pipelines since you'll have to use them again with Direct3D12. Yep. You know what? I'm going to reread that when we come back from ads, actually. Got about 15 more seconds on ads. All right, ads are dead. So, Taman says no point in ditching pipelines since you'll have to work with them, or you'll have to use them again with Direct3D12. That is a solid point. Better prepare the front end to deal with them. So the funny thing is they are completely a back end concept in our implementation here. So in our case, pipelines currently are actually bound to a shader, which you could argue is not necessarily correct, but it hasn't really bitten us yet. Because most shaders also have a expected, input format and number of stages and that kind of thing. To me, it just kind of makes sense to group those things together. So they're part of the shader, which is probably how I would also group it for Direct3D12. So I don't need them on the front end yet. Hopefully I never do. One thing I really miss in Direct3D12 is extended dynamic state, which is what we're actually using now in our Vulkan renderer. We actually switched to using dynamic rendering, and we are using some dynamic state. Oak Spirit, you spent 2 hours trying to move code to another file in C++, and it ended up being in my coworkers telling me it's a compiler bug. Ouch. That's rough. Do you use Valgrind? I do. I have not used it in a bit because we're in the middle of a refactor, but certainly before we go to start making a game, that's one of the things we need to do is pass over the whole code base of the Valgrind. 100%. Because that will expose a lot of bugs that we may not immediately be aware of. So I do have it in mind to definitely use that. 100%. All right. So that can go away. This can go back to a note because I fixed that. And then we could actually get rid of that. And get rid of this. Resize logic. I'm going to leave that alone for right now because our standard UI doesn't actually have any of that yet. When we go to implement that, we'll have an entry point for it here. So I think that's all the plumbing that we need to do to hook up our standard UI system and to initialize it and get everything running with our plugin system, our new plugin system. I think that should be it, right? It's really just kind of connecting the dots between the two. So I'm pretty happy with that. That means we can actually remove some code out of testbed main. So actually we had a fix me here. This should be done via plugin loading interface. Yes. Yes, it should. So the standard UI state here. Let's see, we have plugin states. What did we say we were gonna? Standard UI plugin state, right? Let's actually do SUI plugin state, right? Because that's a separate thing. No, I don't want to change it. Standard. I didn't make it private either. Standard UI plugin main. I wonder if I should move that. Let's see. Let's do include that. That'll give us what we need. And then we can get standard UI state. SUI state equals SUI plugin state state. Okay, so this no longer needs to be here. So that's gone. I am probably going to need these, so I'm going to copy pasta those real quick. And we will take a look a little further down. Let's see, what is... This is our initialization. That's the editor gizmo. Here is all of the... Actually, there's a lot of state stuff here, so actually we're going to be able to fix a lot of errors here, actually. Odd Oculus, thank you for the raid of 34. How are you doing tonight? Hope all is well. Welcome, raiders. So what we are working on here, just to give you a quick and dirty overview. And before I do, Odd Oculus, what did you get up to on stream tonight? There is a shout out. If you're not following Odd Oculus, definitely go do so. He's very entertaining to watch. He uses Unreal Engine to build his game. Little work on damage numbers. Nice. Did you ever figure out that homing issue that you were having the other day? You had an issue with... I forget what it was. I think you were having an issue with like the actual path of the object versus the orientation of it or something like that. All right. So for all of you who are new here to the channel, we are making a game engine from scratch. It's called the Kohi Game Engine. I'll drop some links here into chat so that you guys have that. So basically what this is it's an engine built from scratch using C and using Vulkan as our initial rendering backend. I say initial because we do have plans to support Direct3D, Metal, and maybe OpenGL at some point. It started off as a YouTube tutorial series and then changed formats a few times. And then we eventually landed on sort of live streaming on Twitch and YouTube. So the engine itself is available on GitHub. It is completely open source and completely free. It is Apache 2.0 license, which basically says if you want to use it either personally or commercially, you are free to do so. All I ask is that you say you used it. That's literally it. There will never be any sort of licensing fees or royalties of any kind. It will always be 100% free. So we do have some basic things implemented. We do have some basic PBR in place that we put in not too long ago. Right now we're actually kind of in the middle of a fairly large refactor, so I can't actually run it because my build is broken locally. These are a couple of screenshots of what that looks like, right? And everything that you see here, including all the UI controls and all the rendering and all this stuff was completely built from scratch, including our text rendering. There are a couple of caveats to that. There are a couple of libraries that we use to load images as textures and true type fonts, but other than that, that is pretty much it. And so, if you take a look at this website here, which I linked in chat, we do have a Discord server with around 900 people on it. Here's the GitHub link, Patreon links, YouTube Twitch, all that kind of stuff. Here I am at the bottom, so if you guys wanted to watch the stream from here, you can. And, there's Inception right there. So we are, building the entire thing from scratch, right? And this is mainly meant to be an educational exercise, right? So I'm one guy doing this in my spare time. It's not meant to compete with, Unity or Unreal or Godot or any of those things. I don't have a whole team of people. It's just me, right? But this is a way to build a game engine. It's not the only way to build a game engine. It's not even necessarily always the right way to build an engine. A lot of what we do here is exploration for educational purposes, which means that sometimes you have to refactor things to make them a little bit more usable once you get past the explanation portion. So that is what we're doing here. I hope that makes sense to all of the newcomers. Okay, tweak the design a bit. Still not sure of the final form. It's better though. Awesome. Yeah, that's the interesting stuff that I'm looking forward to getting to once we get past all this low-level technical stuff at some point, for sure. Linear algebra, game dev, mortal enemy. Yeah, I mean, you'll eventually get there, right? Like, we touch on some of that stuff in the YouTube series fairly early on, lightly, of course. We don't go into real crazy depth here because, there's frankly other resources that could explain that portion of it way better than I can. I reduced memory usage for my benchmark program from 6 gigabytes to 12 megabytes using object pooling. Man, that's awesome. Feel so dumb for not thinking about it first. Yeah, object pooling is awesome, for sure. The interpreter is so much faster. That's pretty sweet. Yeah. Object pooling is definitely a necessity, especially once you get to gameplay code, right? All right. So what we're doing here is we have gone through and done a pretty extensive refactor across the entire code base to try and resolve and eliminate a lot of our technical debt that's built up since we started the engine. And one of those things is we have a sort of plugin architecture as far as the engine is concerned. So our engine is essentially, let me collapse some of these things over here. So our engine is divided into a few different sections. We have a core, which is just sort of like a freestanding library that contains basic things like our containers, some debug utilities, identifiers, our math library, all of our memory management, some custom parsers we've written. Our platform code is in here, so we do support Windows, Mac, and Linux out of the box. String processing libraries in here, threading, time, other utilities, right? So that kind of stuff is in here. And then we have a runtime, which is specific to what an application might use, right? So our core and our runtime are separated because we might have like build utilities or something like that that's external to the engine that might still want to leverage some of those types. So we have our core separated from our runtime because of that. So we have our runtime, which is basically the engine is what you can think of it as, right? It's the core of the engine. And that contains things like our application interfaces, our audio front end, our rendering front end, our actual plugin types, our plugin system, all of our various systems, right? So all these systems that you see here for materials, light management, jobs, geometry, things like that, right? Resource loaders that are generic, right? All those things are contained in here. And then we have the application itself, which is actually split into two pieces as well. So we have the application itself, which is just a super light executable, right? This is where the executable is built. It has one code file, and all that is basically just loading up some very light configuration to get you into the games or the applications library. The application library is a hot reloadable library. So you can have the engine running your application. You can make changes to your application code and recompile that, and it will hot reload while the engine's actually running. And so that's where that split comes there. We then have a few plugins that we're working on right now, and we're working on standardizing these things. So our renderer is an example of a plugin, right? So we have a renderer Vulkan plugin. We'll eventually have a renderer Direct 3D plugin, a renderer Metal plugin for those different rendering backends. We have our audio systems also a plugin, right? So right now our audio system is using OpenAL. We could very easily add another system to that if we wanted to. And then we have something here called the standard UI, which is another plugin. So our UI systems are not core to the engine. And I say systems plural because there is going to be more than one. So we have our what we're calling our standard UI, which is a retained mode UI, and we are going to be making an immediate mode UI as well. So each of those have their benefits and drawbacks, different use cases, things like that. And we're going to showcase that here by creating one of each. And so those things are plugins as well. And so in the application itself, you would go ahead and configure what plugins you want to use. Our plugin system will then pick that up. And during the engine boot up phase, we'll actually load the plugins and bootstrap those as needed. And that is what we are working on right now. So I hope that makes sense. I don't know what that link is, so I'm just going to delete that one. Are your plugins DLLs or statically compiled in? They're DLLs. The only exception to that, and that's actually something I'm working on changing right now, is the standard UI technically is statically linked in the testbed application. That's not going to be the case going forward, though. So right now it is. Eventually it won't be. We basically want our UI systems to be completely config driven, which right now we can see that we have a whole lot of code manually being called because we don't actually have a configuration system set up for this. We're still kind of building out the UI system. But this is more or less what the UI system would do under the hood as it's reading the configuration, right? So right now it is statically linked. Eventually it will be dynamically loaded instead. So I hope that makes sense. Okay. Roman General, good to see you over on the YouTube side. I'm doing well. How about you? All right. So yeah, I guess that's the quick and dirty version of where we've come from, where we are, and what we're doing currently. One of the other things that I did is in our Vulkan renderer, we did a heavy refactor on our Vulkan renderer. And we switched to using dynamic rendering, which means that we don't any longer have to use frame buffers or render passes. We do have a render graph though, as well, so that's configurable. So yeah, I think I covered everything. If you're interested in the project, I would encourage you to follow me here on Twitch or over on the YouTube side, or both if you are so inclined. I would greatly appreciate it. It helps me grow the channel and stuff like that. And like I said, this is to be an educational resource because there's not really anything out there like this that exists that shows you how to build all this stuff from the ground up. And so I sort of identified that niche, and we're going through that now. And this series starts off literally with us creating the GitHub repo. So it starts from complete scratch. All right. Cool. Now that that is done, where was I? So I think we said we don't need the render hook on this one because our frame prepare is actually going to handle that for us. And then our render graph pass, or our render graph node for the standard UI system is actually going to handle the actual draw calls for us. So I think this is good to go. I think we were in the process of actually adding our state to all of these functions because the refactor now requires that, right? It's not statically held anymore. It's dynamically obtained, which means it is hot reload safe. So if we do, what did I call that? Because we have state here. I think I just called it SUI state. So yeah, we could just use that. So it should just be a matter of SUI state to resolve most of these. It's got to be there. Don't need that. SUI state. Now this one's bleating about something else. App config. Okay, we'll have to come back to that one. All right, and we'll do that. And I just realized I'm probably coding behind my head, so let me actually kill this window over here. And is my syntax highlighting just like completely pooping itself now for some reason? I think it is. Unless I typed something stupid somewhere. I don't think I did though. Just really doesn't seem to like this for some reason. There we go. Okay. Okay, so this is likely because we don't have the state added. So let's go to definition on this guy. And add state there. All right, so SUI states. Delete that out of there. Right, so like most of what we're doing is just like cleanup of like this kind of stuff, right? Like leftover sort of fallout from our refactor. Are you planning to support FreeBSD? You know, I hadn't thought about it, but I don't see why not. I could do that. I know on Linux right now I only have X11 support. I am supporting, or I am planning on supporting Wayland as well eventually. Now I'm just leveraging X Wayland, but yeah, I don't see why not. And for reference, for those of you who are new, I am on Linux at the moment, actually. Arch, by the way. Okay, so we don't have. I wonder if I should cache that state somewhere instead of getting it like that. Especially for the update. I could store it in the state. So So the test bed is sort of our testing application to test new features in the engine. And that's the driver that we're using for our engine right now. So I guess I could store that in here. Here's all the UI stuff here. So I suppose I could store all of these things. I'm just going to forward declare these so that I don't have to include those types. The Lord's operating system, by the way. Yeah, exactly right. I love it. All right, so yeah, maybe I will do that. Right? And then I can say state. And then that, right? And then all I really need to do is call state or use state SUI state, essentially. So when we get here, I can just do state SUI state. Okay. So this is a bit of that resize logic. That's actually like, I'm going to do a fix me here. This should be handled by the standard UI system resize event. That doesn't exist yet. The event handler. Okay. So this is going to be state SUI state. And then all of these render graphs, so these specialized render graphs are going away. We don't have need for them anymore because now we have configurable render graphs, right? So we're going to stick to one render graph. We're not going to have those specialized ones anymore. And we can just configure the nodes. To show you guys what that looks like, by the way, here's our application configuration file. So here's our forward renderer graph, right? So we have frame begin, then we have a node to clear the color buffer, to clear the depth stencil buffer. We render the skybox. We can do a shadow render on eventually different threads, so we can multi-thread that. And then we have the sort of forward node that takes the color buffer, depth buffer, and shadow map that's been generated by this guy, and actually renders the scene. And then we have the frame end, right? So there's actually two nodes in here that we're going to need to add. So I guess while we're here, we're going to do, I guess we'll do standard UI. And the type is going to be standard UI, right? And then we have ads. All right, Yak and Cheers. No worries. Thanks for stopping by and thanks for being here. Appreciate it. Good to see you. Oh, you're going to do an mruby plugin. Nice. Yeah, that would be cool to see, right? To have different scripting language plugins. That'd be really neat. Once we get it finalized. Yeah, I'm looking forward to that. That might be a post one post 1.0 thing. But yeah, it'll be interesting to see folks adding different things, right? Because this is an open source project, so eventually we'll have some sort of system set up where you guys can actually add those in. Let's see. Roman general. You found a new job coding. Congratulations. That's awesome. Yeah, and I get what you mean about the 2024 tech layoffs. I dealt with that myself earlier this year, so yeah, I feel your pain on that. You're killing it. Keep it up. You inspire me and everyone watching. Love from DC. I appreciate that, Lizus. Thank you. Appreciate that a lot. All right. And ads are dead. So we can continue. So we have our new standard UI node here. And mind you, this is only the node for the actual render graph, right? So we don't actually configure UI here. But that is actually something we could talk about at some point, right? We're not going to probably handle that as part of this refactor, but that is something worth mentioning. The other thing that I want to do, and this is some work that I did sort of offline, is we have a debug pass. And we're going to call this debug 3D. Right, because we'll eventually probably have a 2D one as well. And what this will be responsible for is just drawing those 2D and 3D, or I should say 3D rather, debug shapes, right? And so what we really want to do is we want to, I think all these just need the color attachment. We could argue that the 3D one needs depth, but I don't really think it does. Because it's just lines and stuff, right? So let's do this. I'm going to take this. And paste it there and for standard UI, right? And so both of those are going to have a single sync, a color buffer sync. But those are both going to take the output from a different node. So in this case, it's going to take it from forward, right? It'll take the color buffer source, right? And then SEY will take from debug color buffer. Right, so this will be done in sort of a separate pass. This will make sure that the debug shapes that are drawn in this pass appear over top of everything else in the scene. So we have a separate pass there. We have a separate pass here. Again, drawing to the color buffer, and then instead of forward color buffer, this is going to wind up being SUI color buffer. Right, and so like playing around with our render graph is going to be that easy, pretty much when we're done with it. Right, it's just going to be adding, subtracting, moving nodes around, changing configuration, things like that. That's the idea. So the debug one I added off screen. That one was known as the editor pass before, but really all it was doing was drawing debug 3D shapes. So I just repurposed that, and then the SUI is the standard UI that we're working on now. So you know what, we don't need two of those open. Okay, so refresh render graph PFNs. So the purpose to this was for like all of our, when we hot reloaded, any of our custom render graphs that were like application defined would have their function pointers reloaded here, and this was essentially triggered by a hot reload of the application library. So we don't actually need to do this anymore, because we only deal with one render graph, and that is defined in our application config. So we can actually get rid of that. We can get rid of that call, and then we can get rid of this function entirely. We don't need that. Create render graphs. This is another thing we do not need, because we only have the render graph that is created in config, which no longer relies on application code to create it. So that can go bye-bye. Initialize, same thing. Prepare, same thing. Execute. Guess what? Same thing. Destroy. Goodbye. All right. I love deleting lots of code. Feels good. I always like change sets where I remove almost as much, if not more, code than I add. Feels good, man. Okay. So we've halved our error count once again. So let's see. Load main scene. I don't think that's going to have much of anything in it. Most of our stuff is with application boot now. So what does debug console create want? That wants the SUI state. Okay, so we apparently are not right. So this happens during initialize. We don't have that during boot yet. I feel like boot might be too early for that. I feel like we're doing this because it is also console consumer, so that it can pick up log messages early. In fact, I'm positive that's why we're doing that so early. I'm just worried that this might not be stood up yet, and I'm thinking it probably won't be, but initialize render graphs. Oh, you know what? We can get rid of all those too. This doesn't need to be there. Create render graphs. Okay, that could definitely go away. If we were doing that here, then we just need to make sure that our plugins are loaded pre-boot. So plugin system. Oh good, that's done way early. So plugin system initialize. Oh, that's interesting. I suspect we might run into some issues with that. But okay. Resolve configuration per plugin. Okay. All right, so all right, at least I know that this is happening in time. So actually what I can do is this Well, yeah. That can happen there. Right. Let's just do state equals state, right? And then we could just do, I don't know why I just didn't do that before, but fine. Okay, so this needs that. Okay, so font config stuff is the next thing that we need to think about. So the reason this is here in our application boot as opposed to our initialize is because when we stood up our font system had this concept of default fonts that needed to be loaded up during the system startup, which is no longer a concern. So really what probably needs to happen is like we have some sort of default stuff that's happening here that really should be part of our application config that then gets read in by the font system instead of having all this hard-coded crap here, right? That like this is the kind of crap that we're trying to get away from. So I think let's see what that would look like in our app config. So let's see, config. Let's see. Font config. I don't know if I have that anymore. Does not look like it. Okay. So what this font config is part of our application config, which I don't think this actually exists anymore. I think we ripped that out of there. We did. So technically that is font system config is what all this stuff is. So let's translate this to that. So we have our system config here, right? So this is our renderer. This is our plugin system, which contains plugins, which has config for each one of those plugins it loads. The order of these things, I don't think... Well, I mean, it definitely doesn't matter, right? So we can do... we'll say the name of this one is... I guess we'll say font system, right? And then this config will be pretty specific, right? So we're going to say... I guess we'll do auto release. So we had false there. I guess that makes sense. So basically what that means is like when a font's reference counter reaches 0, does it auto release that font and then force it to be reloaded whenever we want to access that font again. I'm saying no to that. Default bitmap font count. I suppose we don't really have to have a default font, right? But I suppose we could do default bitmap font, right? And we can declare this as an object. And then its name. Oso0, thank you for the follow. Appreciate that. Its name will be Ubuntu mono 21 pixels. We'll say its size is going to be 21. And we'll say its resource name is going to be Ubuntu mono 21 pixels, right? So the resource name for a refresher lines up with this guy right here, right? Which is, in this case, a bitmap font with a listing of all of our character codes and where they are in that font file, right? So that's what that is. So that's our bitmap font configuration. And it looks like I'd set that up as an array to be able to accept more than one, but I think we're just going to go with one. And then we'll say default system, font, right? And this will be sort of an object as well. So our default system font name is going to be Noto Sans. The size will be 20 pixels. And the resource name, will be Noto Sans CJK. And that's the Chinese, Japanese, Korean variant of that font. So it contains all the glyphs for those languages so that we can test UTF-8 stuff. So we have that. And believe it or not, that is most of the config that we need. I'm going to go ahead and plug these other values in here for now, which is the max bitmap font count equals 101 and max system font count, which is also going to be 101, right? Prime number for our hash table lookup, right? So that's what I'm going to say for now. I might refactor that to not actually be required here, but for now I'll just, since it's here, I'll go ahead and translate it over. Okay, so fonts can actually go away. Don't need that, right? It's just part of the systems configuration now. All right. So the next thing is editor render graph gizmo set. Okay, so oh, you know what? There's a couple errors here I have to fix too, because this was SUI state. Let me do this. Standard UI state SUI state equals state SUI state. Right, let's just do that. Oh, that cut the error number way down. Okay. So the way that this used to work is we had a separate sort of editor render graph, which now no longer exists, where we could set the gizmo as part of that, right? And then whenever we would execute that, it would be responsible for drawing the gizmo. We obviously don't have that now. So it would be really up to this node to actually set that, right? Which we actually don't have a reference to that. So let's put a tag in that for right now. Set in debug 3D Render graph node might want a way to reference just the geometry and not have to maintain a pointer in this way, right? So rather than setting the whole gizmo, I would like to be able to say, okay, what state is the gizmo in? Which piece of geometry should we be actually rendering? And then pass that over to be used with this guy instead, right? So we're gonna come back to that one. Okay, so this control position set. So this is using, this is actually wrong, incidentally. This is using the app config's initial start height, like the Windows start height, minus 75. So this using this to move the debug text to the bottom of the screen, which is, that's wrong, right? It shouldn't be using the initial configuration for that. It should be using the current height for that. So do we have application and resize. We do have state width and state height. So actually that fix is going to be pretty simple. So what we should be using is state height minus 75. Right. That way, no matter what the window size is, it should just follow it, right? Now, I think this is just initialization, though, so I think I have a suspicion that this is actually done correctly elsewhere. Okay, so prepare frames, prepare render graphs. Get rid of that. Technically, this means that we don't need this prepare clock anymore. Anything to do here? Let's see. When we render the frame, again, I don't think there's actually going to be anything to do here. Right? I think this should be just maybe just executing the render graph. But that should be it. Destroy render graphs, that doesn't exist anymore. See ya. Okay, so now all we have is the gizmo set, which is the remaining two errors that we have in the file. Okay. So, one thing that we don't have I don't think we actually have a reference to like our render graph itself. Render graph creates. Right, we have all these specialized render graphs, which are no longer in use. Yeah. So the next thing that we're going to have to do is we're going to have to obtain our render graph configuration from our app config and use that to actually build our render graph. So here's the configuration string. So we pass it the configuration string. I think I already set up all the parsing for this too, actually. Yes, right there. So we already do all of that. So all we actually have to do is actually pick out this entire section, right? So we have to grab the render graphs and the configuration for this one, right? Technically, this is an array of render graphs. I'm not sure that we're going to need more than one. I suppose that's one other thing we could think about, right? Theoretically, at this level, I don't see the point in not supporting more than one. And then maybe we just leave it up to the application as to which one it uses. Maybe we can have a few different render graphs that I can use and switch between. Maybe that's, yeah. Just have that be completely up to the application. So what we really would want to do is extract this from the app config. So we would want to do that in initialize. We wouldn't want to do it before. Register resource loaders. I suppose that makes sense. Okay. So I think we should do it here. Pick out render graphs config from app config. Create init them from here. Save off to state. Let me see. Okay, I think this is probably actually a good stopping point for tonight. Let me build really quickly. It should get to this file and then throw up, basically. Okay, that is one other thing we're going to have to fix. But I think I'm going to wind up removing that. So, all right, I'm not going to worry about that for tonight. We did make some pretty big freaking headway tonight, which I'm happy with. So, let me see. So yeah, if you guys can see that, I'll move it up a little bit. We modified quite a few things tonight. So I'm pretty happy with that. Work in progress, testbed, app config, factor. All right, and I'm going to push this up to the feature reorg branch, just in case you guys are interested in having that. All right, and let's kill that and make a new session. And that, I think, is where we're going to call it tonight, folks. So let me find somebody to raid. Let's see who is on. Boy, there were a lot of people on earlier that I really wanted to raid, but it looks like they're all pretty much done. Let's see. All right, I'll tell you what we'll do. For tonight, we're going to go ahead and we are going to raid Ferret Software. Just because it's a good cause, I like to support it whenever I can. So this is a ferret rescue that is run by Pirate Software, who is another streamer here. You may or may not have heard of him. He's only like the biggest programming streamer on here at the moment. But anyway, he runs a ferret stream, a ferret rescue, for which this stream's ad revenue pays for, just by running the stream on the screen, and just by having it up and letting the ads run. It handles all of the bills for the food, the medical care, and everything that the ferrets would need. These are ferrets that have been taken in from situations where they were very near death, and in a lot of cases needed severe medical help. And they're permanently homed here. They don't get rehomed. They don't get adopted out. They're there for the rest of their life. And it's a really good cause, and I like to support it whenever I can. So, yeah, I'm going to go ahead and do that. Thank you guys so much for following me here tonight, both on the YouTube side as well as on the Twitch side. If you guys haven't already, I would encourage you to toss me a follow, like, subscribe, whatever, all those things in all the places. Here are my socials if you're interested in that. And we will see you guys next time. See ya.